Hello everyone, this is Bradley. The following video is about my voice recording to make this Lycoris Radiata model. It's completely procedural, as you can see from the demonstration. And just so you know, I don't have an actual plan to make a tutorial for this setup. So this voice recording may be everything you have. And I highly doubt the quality of it because I was very tired when I recorded it. And since it was a complete experiment using repeat node in 4.0, I have no prior experience with it, or my experience is not enough to make this entire recording clean and clear. So yeah, so anyway, let's start with a node tree. So I don't know what I was thinking when in the past I was trying to do this, but technically speaking, it should be very simple. So I take a repeater zone first, just to make my life a little bit comfortable, and I take a loop index. I try to explain as few as possible because I need to concentrate a lot of what I am doing. I don't think I'm going to make a tutorial for this kind of thing because it's basically just a repetition of some simple stuff. While it's very complicated and it's time consuming, that's why I make this as a voice recording, which if you're interested in, you can follow. But I don't think it should be very difficult for people to really make their own. Anyway, so we have this repeater zone. This is also a very good opportunity to really learn about or try repeater zone. The reason I add this loop index is because I need a seed. So I take this curve, I take a curve linear, and I only need to join geometry for every iterations. Okay, I join geometry for every iterations. So every frame I'm adding a new spline, and I can rotate that a little bit. In this case, I think I can just put a transform. Sometimes transform node will show you kind of errors if you're using any field inputs, but it should work in this case. Let's take a random rotation, just a little bit. We take this as a seed and we use a integer. You should it should probably does not really matter with it, and take it 0.1, and by increasing the iteration we have more of them, so we can increase the value a little bit. And we are going to rotate these lines. So we take a set position. You realize there is a kind of red indication of bug, but technically speaking, there is no bug because every line is solid and so on. But I hope a developer can resolve this misalarm, because it will be very difficult for me to explain the tutorial why this is working, why other times it's not, and so on. So we take a set position, and I take a vector rotate to take the position. Of course, we can also use the set position to vector rotate, but it's not something I like in this case, because it may create some issue. If I use an x-axis and I use a spline parameter. Okay. So now if I just remap 0 to 1 and I take a randomness. If I take a randomness and use that as a seed, we take we can also use the custom ID. I think it works better now, so that we're actually generating a single value. Okay. So we created something like this now. I will just keep it. And we take an index seed so that we can actually generate different values. We have this index input to seed, but we can give different seed for them. And this is a procedural setup. Okay, so we created something like this, and I can instance a sphere later. I can bevel curve. Okay, so it becomes like this, and I can also point instance a, let's say, UV sphere, and I'm going to stretch it a little bit. It does not going to be high poly because it's going to be very small. So I take a transform. So maybe just a stretch a little bit, and then we take a randomness so that I can get a different scale of it. We may want to align everything properly at the end of this spline. If so, then can't I just align Euler to rotation? No, alignment on splines. Jesus Christ. This is almost midnight, so I'm a little bit tired for a day, and I only end up on selections. Something like this. Okay. And then we join geometry. So we finish the very basic part, but at least this is working. By default, a geometry node tree is actually a group node. That's why you see group output and inputs. But I may just group them separately. I don't know how to call this part. Maybe I should call it a statement. Let's just Control G to make it into a group node. It's very important. You do not need to really do this. But I think it will be better if you do, because there are so many parameters that we need to access For example, we need to access the rotation. So we take this average, and I can collapse the node. Also the rotation, maybe also the length, but I do not want to worry for now. For seed, the reason to have this seed index is because I need an additional offset to it, so that we can drive this seed outside as well. And we also need a scale for this randomness. But I think this is fine for this moment. Okay, let's just keep it as it is now. So we only have this setting for the moment. This is the setting for rotation. Okay, so let's rename it. I have an angle, and this variation is for rotation as well. So just name that as rotation. It might be a little bit confusing, but hopefully it will work. At the end, you do not really need to know this functionality, because we will just use any random value to it. So next part, we basically do very similar thing for the next part. So we take a repeat zone again, and I need a loop index. People already suggested to add this loop index functionality into the loop node. Well, the developer, Jakes, is the core developer, or actually the parent of animation nodes. And I used the animation nodes to build my first Lycoris Radiata. So he must know what a loop node really needs, but I don't know why he didn't really implement all this kind of functionality at the first place. So sometimes things happens. Oh, basically actually doing 100% the same. Can I really just copy and paste the node tree? So I'll just select this node tree and then copy paste it. And then I'm pasting it. Okay, so now I have this curved linear. I can delete it, and I just join geometry. So now I see it. Okay. Yeah, very nice copy pasting. And we take this loop index, but we have to change some parameters. Let's take some iterations so that I can actually visualize different of them. So one is they need to get out very much. Another thing is their angle. I also noticed that currently this angle is towards a specific axis. So I this time I want them to get a kind of a splashing shape instead of towards one direction. So I'm not going to choose the x-axis. I'm going to redefine the x-axis. So how do we define this axis? This is a very tricky question. I think it's something related with the rotation. Can I try to rotation to vector? It's not rotation to vector. It's just a trial because I really don't know for the moment. Okay, z-axis is not working. Can I try x-axis? Not working as well. I need to align Euler because it's not simply the rotation towards some direction, but I need a second vector. So I take align Euler to vector, and this is tricky now. We have this rotation. Let's take to -1, so that hopefully it's not helpful. Technically speaking, I don't really know what I am doing. This is very tricky now. No, actually there is an easy solution, because if I want them to face downwards, oh no, it's actually if I want them to face downwards, then if I do not really know this vector rotates, there's another thing what I can do is just to offset this value, the z value, to make them go downwards. And this randomness just go down. And I can tweak this flow, this spline parameter. So we have this effect. I don't know what I did in the past. And we can tweak it. So now we have this. Not really perfect. And we may increase the amount of smoothness. But you get a kind of idea. This is not necessarily a very good solution, but I think it gives what we want. Yes. Okay. So I think this is the petal part. So let's add another thing. Let's take a bevel curve. Actually, there are many ways to do it. So set curve normal. So take the up, because instead of a tube, I need a curved linear. So we get this effect. But this is the tricky part, because I'm going to deform these edges. Deform these edges. One thing I need to do is to set curve radius. Here, what if we do not set this curve normal? Okay, it's still working. What I worry is if they rotate to other angle, which will make my life miserable. But fortunately, it doesn't happen. Okay, so right now I have this, and I need to set curve radius. Take the spline parameter, and I need to reverse it. So let's take a float curve. So we reverse this relationship, but I want to keep that large, something like this. We can also resample it. I don't want to resample it. I'd rather to just increase the count. Hopefully this works. And we set the cuts like this. And this actually becomes very tricky, because I need to deform these points on left and right. Make it a little bit noisy. There are many different ways. For example, I think the simplest way is just to tweak this radius. As you can see, this radius is giving different thickness. So if I use a random value, so if I just use a random value, we can just tweak it and add to it. It becomes a little bit noisy. So if I add a noise 3D, and we need something to drive. Do I really need? If I just increase the frequency, okay. Can I try to multiply? If this is multiply, we multiply to 1. Decrease the frequency. So we get something like this. Of course, this is not perfect because we don't have other curvatures. This becomes a little bit tricky because how do I select the midline? I can add a cuts. That's okay. I think it's possible to select this midline because this midline is not at edges. So we can select based on edge neighbor. And if the face count equals to, let's say, 2, so you can actually see the selection is highest in middle. Okay, so now if I take it, we have this selection. We can do it. Okay, that looks fine. It's not 100% perfect now, but I think this is acceptable. This is acceptable, and we can definitely add a random value to this as well. But I do not want to make too many parameters for this moment. I want to keep everything simple as possible. So let's just make this into a group node for now. So we select everything and group them. And I need to output several things. One is these iterations. And we also need these parameters. Let's name as a rotation. And I also need this angle. It's not really called angle now because we are using a different way. But I think it makes life a little bit easier. We may also tweak these kind of settings. Combine XYZ. Can I try combine XYZ opposite way? It does not. Because I was hoping this value can actually go back to the combine XYZ. As we previously see that if you use an integer, then you actually have the value coming back. But anyway, people won't really care about the random value here, so I'll probably ignore that. But you can do that. Okay. So I have this. So now this is the flower petals. So LR petals. Okay. So several days ago, I was so tired, so I went to sleep. Actually, I no longer remember why am I, because there are so many group nodes. But I think we have this statement, we have this petal. Let's just take a join geometry so that we have this flowery unit. And then we just need to create the variations of this flowery unit. Okay, so let's take this, before I group it, let's just take a repeat zone and put this repeat zone back. And then we need to create all these kind of variations. So I take a loop index. As you see, it might be better if we have this built-in loop index in the repeat input. But of course, it also creates the problem that maybe the design will look very weird. But anyway, so we have this loop index and we can plug that into the offsets, I guess. Why don't I have offset in petals? Don't I have random value? I do have random values. So let's put these offsets back. I'm thinking to add a new offset in this index seed, because in this case I want to create a different random value for different random value in this offset. Okay. So that even if both are offset 5, they should get a different random seed and so on. Okay. So we have this, and let's get randomness. The good part of having this randomness node is that you have an average. So I just need to type 0.28 and I link with the custom ID or link with seed. Link with custom ID, I guess. So that we create variations. I just duplicate that and I type in 0.21 to link with the rotation. And I link with 1.04 to link with the rotation. I type in -1.2 to link with the angle. And I get another index seed again. And I have seed 1, I have seed 2. Okay. I noticed some problem with this one, but we may fix that later. Okay, so once we have this set up, I don't think I need to input the geometry, but you just know that by increased iteration, we're alright, it's not happening. So we need to join geometry. You can duplicate a new join geometry or directly plug this into. But I try to just use a new geometry. There's no reason to do this. It just makes everything look a little bit comfortable, in my opinion. And if I put the iteration 2, you can actually see two flowery units is basically colliding with each other. So here, what we are going to do is I take a join geometry to instance. So I can delete this join geometry. It does not really matter because they will be joined at the same time in this case. So that we have a single instance being. Okay, I need to join geometry. Otherwise, there will be two separate instances. Okay, so I have this join geometry, which is okay. Yes. So now I'm outputting lots of instances. Now this is 2. And what I need to do next is just to create this kind of branches. So we start with a similar setup, just like what we did to create all these kind of stamen. Is that called stamen? Yes. So let's create a lot of curves. So we start with a curve linear, which should be a straight line to the top, and we take a point instance geometry, which is basically like a duplicate elements, but we can set the position, rotation, and scale. Sometimes I do not really like the duplicate element node. That's why I implement this. And we just need a random rotation. Set the value to 1, I guess. Something like this. And I do not need many numbers, maybe just 5 count. Okay, something like this. And we can get a random scales, randomness, to have value of 1. Plug that into scale, and then we realize the instance. We separate geometry. I only need these endpoints, or actually, let's just separate geometry. I think it will be better because I need to take a domain size to know the amount of points I have. I think this is the curve. So I think this point counts into iteration, so that we are creating equal amounts of this Flowery Unit instance. Maybe I should group it, but I'm not going to do that now. I already feel too tired to keep grouping all this kind of nodes, because if I have to change something, it feels like I have to keep going into. And finally, a point instance. But as you see, if I don't group it, then I will have this very weird whatever. And now I have this weird stuff happening. I pick instance. Okay, so this is fine. And actually, it may not be too good idea to separate the geometry, because the tangent and the normal will be disrupted if I need to align them. So I take follow splines so that it generates an endpoint automatically while it keeps the rotation tangents together. Oh, this is a perfect idea. And this point cloud. Okay, this is perfect. And I have my rotation, so I just plug this rotation crossing billion miles to this rotation. Okay, so now we have this kind of effect. We can also deal something with the scale. Looks kind of very weird, but I think it's just a parameter thing. So let's take a value precision down. Oh. Am I dealing the scales generally? Oh. This is an interesting question. Oh, because the offset should be 1, so that's there at the sky. Okay. I didn't notice that. So now if I have, maybe I should just keep the scale at 1. Yeah, it looks fine, something like this. You get that kind of idea. You can decrease the variations. This is a parameter thing. I do not want to deal with it now. Okay. And we need to join geometry so that I can see the original spline. And I need to bevel the curve to give it a thickness. Bevel curve. Looks kind of too thick. Just to decrease the radius. Maybe now it looks too thin, but anyway. Okay, but anyway, we have this we have this weird whatever now. Maybe it's not too Maybe we should decrease the size. We have something like this. Okay, it's not perfect yet, but I think we are close to the answer. Now I noticed that the initial implementation of these petals is not perfect, but I think I will move on now. Should I? So let's re-implement these petals. I'm going to change a method. Let me think. By the way, it becomes very difficult if you're working with all this kind of group nodes or repeat zone, because it's very difficult to out-shift the result. It will get a temporary viewer, and sometimes it's very annoying to delete or cancel it, because it may disrupt many things. So this time, there's a benefit that you use this viewer, but this viewer will only show you the first result from the loop. So sometimes you have to imagine what's really going on. Anyway, so the current method of using this set position is completely wrong. It's not wrong, it's just bad. So I think I will disable this method at all. Let's deal with this transform. I don't remember what I did previously in this recording. I think initially I was using a method of vector rotate, and then I switched to this method of set position. But anyway, I think I'm using a different method. Let's use a band deform. This is basically copying the code of a band deformer. And you know there is a many downside of band deformer. But once we have this curve towards the sky, then it will work very easily with this band deform. Okay. You can achieve the same results with set position and vector rotate. But yes. Anyway, so let's take a randomness. Do we need an angle? Do we need a parameter? Let's just use this angle to replace it. Ha 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 ha. And we will fix the parameter later. Once we have this band deform, next we need to rotate it. So rotating it contains several issues. One is I want the downside to keep it down. So we align Euler to vector to keep the x-axis towards bottom. I don't know, y-axis, z-axis, z-axis, rotation. I think this is fine. So we go outside and change the parameters of it. So now you realize this is very difficult. So let's just duplicate it so that I can actually see how it's changed the parameter. So I take the rotation to 360 degrees. Oh, I realize it's working. And I just put this angle. Okay, it's working, but something's not perfect. So what can I do? Using x-axis? Okay, I know what I want to do. Let's take a rotate order. And if I turn this y, yes, you see this result. So I just combine Euler rotation so that I can add a random value, randomness, and I take this rotation back. I don't know how to name it, just name it as rotation B for the moment. And I need about 40 No. Yes, something like that. And I take this rotation as about 40. It's not working. Why is that? Oh, because I didn't change this index seed. Yes, now this is working. Fine, this is perfect now. So now it looks much better, and you can change the seed to check how good it is. Okay, so we get something like this. I think this is good now. So now if I review, the parameter was not okay. And we need to deal with this rotation, of course. So we'll take a new randomness. We need an index seed. Actually, I'm a little bit confused. Anyway, so change that. Okay, I think now this is fine. You can still tweak some stuff. And I noticed there's some other issues. What is that? I think it's just some kind of a clipping when we have this noise. Is that the noise we're having? No. But oh, something's wrong. If the curve normal is bad, because this is not a z-up. But isn't that just a parameter thing? I can disable it for now, because currently there is no problem. And let's turn on this set radius, because everything looks fine now. And I'd say this is yes. And at the last we want to, so this is currently a single flower whatever. And we need to group this again to create a variation so that we have more flowers. Before I group them again, let's duplicate this setup, which we may use again later. Okay, so I just shift the D to duplicate that, and I go out and group this entire big node tree. Hopefully we will have a kind of a frame system. So that I do not need to keep a go in and out with all this whatever stuff. And I take average, just to make sure I have parameters available outside. And I can take an index seed. I hope there is a functionality built in Blender, because obviously 3 seeds are not enough. But for the moment, I think this is fine. Just giving these variations on the top of variations on the top of variations. So this is basically a single flower. Okay, and I have the previous parts being done. Okay, so I have this is a single flower, and I need to repeat it. Yes, I need to repeat it. Jesus Christ. So I take loop index. Jesus Christ, I have to keep repeating this entire process. How many times have I really done? Like if I look at, I have already 1, 2, 3. It's not really that much. Why do I only have 3? I feel like I have much more than that. Okay, anyway. So I take this loop index into the seed. And I create iterations. I have the amount of points we domain size yet with the points cloud, set the amount of iterations, and I join geometry. I geometry to instance. It's a mesh for the moment. So we take a geometry to instance. And I join geometry with these instances. Okay, so now it becomes too crazy, but it looks kind of very fast now because I have no issue with the viewport. Oh, this is so nice. So I join the geometry, so I bevel this curve. I have these things, yes. Maybe I will do this a little bit differently. But for example, let's create a grid. Maybe this is a 5-5 grid, and I point to distribute, and I instance my point instance a curve linear, and I can set this rotation. So it will be the same, but I decrease the rotation. I use the scale. Okay, so it makes a difference. And I realize this instance. Okay. So a little bit different, but not too different. And we point instance. We have this whatever stuff, and we point instance. My loop geometry pick instance and rejoin it. Okay, so now it looks like this. Everything is too big, but anyway. So I have these rotations. So yes, now I have this. Maybe you do not really realize what's going on, but I think this is it. This was an experiment. So this entire process may not be really good. Maybe I can optimize some workflow. But that's why I do not want to make a tutorial for this, because I noticed how dumb this entire process is. But it looks cool now. Once you finish that, of course, you do not really worry about it. The rest is parameters. Everything I have to rename all this kind of thing, otherwise they all look the same as average while they mean different functionality. And it really looks kind of cool. And they're completely different. Performance is also okay. So for now, I would say this is it. I'd rather tweak all these kind of parameters and set materials later when I'm more free. And perhaps I can add the leaves to this flower as well. But I'd say this is it. And just to clarify, I don't think I will make a tutorial of this. So this noding is yet. Because as you see, making a tutorial is really pointless and tedious. So I hope you enjoyed this video. I'll probably see you next time. Bye bye.